So in the previous videos, we looked at different types of design patterns. So we looked at creational design patterns, which are used during the process of object creation, and structural design patterns, which tell us how we can assemble objects and classes into larger structures. And in this video, we'll be looking at behavioral design patterns, which helps us take care of effective communication as well as assignment of responsibilities between different objects. So let's look at one behavioral design pattern known as the iterator design pattern. So what is the problem which this design pattern is trying to solve? So we use different types of collections, right, in our algorithms. When we store data, it can be lists, it can be queues, stacks, and trees. And a common operation which we have to do is to access as well as iterate through various elements in this collection. So it can, for example, it can be a list of products, right, which can be stored maybe as a list. It can be a list of orders. It can be a list of deliveries, right? So all of these are collections, and a common set of operations are accessing them as well as iterating through these various elements. Now, as a client, I am concerned only with accessing these elements, right? I am not really interested in how these elements are stored or what is the underlying data structure which stores these collections. So the iterator design pattern helps us to separate the behavior of how the elements are accessed into a separate object called an iterator. So you all must be familiar with the iterator interface in Java, right? And the iterator interface in Java has two key functions. One is hasNext, which returns true if the iteration has more elements, and next, which returns the next element in the iteration. Now let's look at how we can implement the iterator design pattern in our code. So let's say we have a book class which contains different parameters like ISBN, title, cost, right? And we have a constructor. And now let's say I want to store multiple books in a collection, right? So I create, let's say, a collection, right? A list, an array list of books, right? Which takes, say, 3 books, and I add B1, B2, B3 into this array list. Now what I can do is create an iterator. So here iterator is an interface already defined in Java, right, which has functions called hasNext, which will return true if the iteration has more elements, and next, which returns the next element in the iteration. So other classes implement this interface, right, and these methods have the implementation details of how to iterate through the collection. So I create a book iterator object, and in this case, if you see, array list implements the hasNext method of the interface, right, and the next method of the interface. So as a client, I need not know what are the implementation details of has, next, and next of these methods, right? Because that has been delegated to the specific collection which we are calling. So similarly, I can create another book list, which is a collection of books which are stored in a linked list, right? And I can create another iterator, right, on this linked list. So similarly, linked list will also have implementations of has, next, and next, which I can use to access elements in my linked list collection. Now let's look at some pros and cons of using this design pattern. So what are some advantages? One is that it follows the single responsibility principle, where we separate the access of elements from other functionalities. So even in our example, we saw that the accessing the elements has been delegated to a separate class known as the iterator, right? Another advantage is that it helps us implement the open close principle. So let's say I want to implement a new type of iterator, right? So I can create or extend or implement the iterator interface in Java, or create my own iterator, right? And this will help me iterate through different or new types of collections. What is the disadvantage? So one disadvantage is that, let's say we have simple collections like maybe an array, right? It might be an overkill for you to create a separate iterator class for simple applications and which have simple collections. Another type of behavioral design pattern is the observer design pattern. So let's say you want to implement a feature where you want to notify a particular set of buyers when a new product is launched, right? And most of you are familiar with such notifications. So you might be getting such notifications in several of the apps which you use, right? So let's say you have subscribed to a channel on YouTube and the channel posts a new video, right? And if you have subscribed to notifications, you would get a notification that this particular channel has uploaded a new video, right? So you as a subscriber, you get a notification when there are updates, right? And I do not want to send this notification to all users of my system, but only to those who have subscribed to get notifications, right? So how do I solve this problem? So this problem can be solved using the observer design pattern. So what happens is that the subject object, it maintains a list of observers. And as and when there are updates, it notifies, the subject object notifies all the observers of any updates or changes, right? So let's look at the class diagram for the observer design pattern. So we have a subject class, right, which maintains a collection of observers. The subject class can register, unregister observers. And we see that the observer is an interface, right, which has a function called update. And there can be other classes which implement this interface, right, and implement the update method. And now the subject has a method called notify observers, which simply iterates over the collection and calls the appropriate update function. Now let's see how we can implement the observer design pattern. So in this code, we have an abstract class called observer, right, which has the key function called abstract function called update, right? And we have two classes. So let's say a normal user and let's say a prime user. Both of these classes extend the observer and they implement the update member function, right? So for a normal user, a message can be sent to the normal user saying that a new product has been released. Whereas for a prime user, you can also send a message saying that you're eligible for additional discount since you're a prime user. So different types of observers or users can be created, right? And now we have a class called subject which maintains the list of observers, right? So the subject can register new or create or register new observers as well as notify observers. So notify observers just iterates over the collection and calls the update function which is present in the implementation of the observers, right? And now the client, they create a subject object, right? And let's say we create two observers, one is a normal user, one is a prime user, and the subject can register these observers. So these observers get added to the observer list, and the subject can, let's say an update happens or let's say a new product is released, then the subject has to just call the notify observers function, right? And the appropriate update function for each observer is called. So for example, for observer U1, the update function of normal user is called, whereas for observer U2, who is a prime user, the update function of class prime user is called, right? So similarly, you can have new types of users and the appropriate update function gets called for each of these users. So if we run this code, we see that normal user and prime user have been registered, and the message sent to the normal user is different from that which is sent to the prime user. Now let's look at another design pattern known as the strategy design pattern. So let's say you want to implement a feature where you want to process shopping orders based on different strategies. For example, one strategy is first in, first out, where the orders which come first, they are processed first. Another type of strategy can be based on priority, right, or based on type of user. So let's say prime users or super users, they receive a higher priority and hence their orders are processed first, whereas normal users' orders are processed later, right? So to solve this problem, you can use the strategy design pattern. So in the strategy design pattern, you extract different strategies or algorithms into separate classes. So for example, you can have a priority class, right? And you can have another class which is the first in first out class, right? And the original class, which is known as the context, it delegates this work of implementing this algorithm to the strategy object, right? So in this case, you can have two strategies like strategy A and strategy B, which implement the interface strategy, and the algorithm is present in the execute method, right? So the original class, it delegates the work of implementing the strategy or the algorithm to the strategy interface. Now let's look at how we can implement this design pattern in our code. So the code on the left, right? This is the code before we implement the strategy design pattern. So we have a class called order, right, which contains the product name, priority, right? And we have an order manager, which takes a list of orders, and you can add individual orders to the list. And this manager has different methods based on different strategies. So let's say you want to deliver the orders based on first in first out strategy, then this method can be called. Whereas now if you want to deliver orders based on priority, then this method can be called, right? And we create orders and we add them in the order manager, and in this case the orders are delivered first in first out, right? Now let's say I want to implement another strategy, then what change would I have to make in this code? So I would have to add another method here which implements the new strategy, right? And this in a way violates the open close principle, which states that objects or classes should be open to extension but closed for modification. So in this case, we are actually modifying this class, right? And that may not be desirable in most cases. So now let's see how we can implement the strategy pattern for this code, right? So here we see that we have the order class, right? We do not make any changes to that class. And here what we see is in the order manager, we separate out or we remove these methods which implement the specific strategy, and we create an interface called order strategy, which has a method known as deliver orders, right? And now we create separate classes, for example, first in first out order delivery and let's say priority order delivery, which implement this interface order delivery strategy. And whatever was the logic for this method, right, deliver orders first in first out, that is implemented in the method of this class, the first in first out order delivery. Similarly, for priority orders, you again implement the order delivery strategy and implement the deliver orders method, right? And now you add orders as before, you call the order manager, and now you create another object called a strategy, right, which takes the respective strategy which you want to implement, and it calls the method which is extended, right? So here you can see that strategy, initially we call the first in first out strategy, right? And we delivered orders based on that strategy. Then later on, for some other condition, maybe you want to change it to priority order. And that can be easily done in this case, right? And now later on, if you want to implement a new strategy, you need not make changes in any of your code, right? In any of the existing classes. All that you can do is create a new class, for example, class new strategy, and that will implement the order delivery strategy, right? It will implement the deliver orders, and you can call and you can create a new strategy and call the deliver orders of that new strategy. Now let's look at some of the pros and cons of this strategy. So what are some pros? So as we saw, the strategy design pattern, it isolates the implementation details of the algorithm, right? So each class will have a logic for a specific strategy. And we also saw that it helps implement the open close principle, right? We can introduce new strategies without changing the existing classes or methods. And what is the disadvantage? Well, let's say our application do not require many algorithms or strategies. We just have one or two strategies, right? Then we need not actually implement the strategy design pattern. So to summarize, we looked at design patterns in the previous few videos, right? And design patterns are nothing but templates or descriptions of how objects and classes should be arranged, should be organized to solve a general design problem in a particular context. And we saw different types of design patterns, right? We saw creational, structural, and behavioral design patterns. And we saw some examples of each of these design patterns. So there are several of these design patterns. So there are around 23 such design patterns, and we will not be covering all of the design patterns in this course, right? But the key thing to remember is that when you encounter a problem, you can always use one of these design patterns to create more extendable and understandable code. On the other hand, we also should realize the benefits as well as the drawbacks of using a particular design pattern, right? And the existence of a design pattern does not mean that we can use that design pattern in any context, right? And design pattern should not be used blindly, and it should be used only if you see that there is a benefit in using that design pattern.